Here is an operator checking a traditional Scada screen. There appears to be a lot of detail, but very little information on how well the system is running. The operator must click through a number of screens to check trends and see all the equipment that is running. Then, a slew of alarms come in, but they're all red. He must now scan through every low, medium, and high alarm, as well as events to try and find the higher criticality alarms. Then, either remember the SOP or look it up. All that wasted time could be catastrophic. If only there was a better way. WME has created a standard, a hero, to save the industry from inefficiency, fatigue, and variability amongst operators. How was this achieved? By utilizing Abnormal Situation Management, ASM, and Wonderware's Situational Awareness library. These word clouds, showing the core concepts in larger text, are the building blocks for that development. The ASM Consortium is an industrial standard that was founded in 1994 by creating a new paradigm for the operation of complex industrial plants, with solution concepts that improve operations' ability to prevent and respond to abnormal situations. And Wonderware's Situational Awareness library has aided in proper plant situational awareness, therefore improving the operation team's ability to make effective decisions that will deliver overall business success. Using these two building blocks, we see WME's word cloud, which is based on WME's tech memo for HMI development. WME has adhered to strict programming and development guidelines in upgrading 3 facilities with over 100 MGD capacity, utilizing 84 Schneider Electric Unity PLCs with more than 15,000 I/O and a Scada system developed with Wonderware Orchestra system platform. The challenges of developing a new Scada application are that we now have larger systems and an increased span of control. We're looking at greater volumes of data, which increases the load on the operators. There's an increased level of automation, and with that some unintended consequences, such as alarm flooding and abnormal situations. Situational awareness is not just a lack of color or muted graphics, but a better way of navigating. Alarm aggregation, information prioritization, and to present information with context, which increases detection of abnormal situations before an alarm occurs. The cornerstone of the idea is that an operator has only a certain amount of time, and we want to use it in a way that makes the most impact to the objective. This is the new Scada screen hierarchy. We'll start at level 0, where we show operations a clear look at how each site is performing. It presents aggregate data of multiple sites. Is there a critical alarm active at the site? We list the pertinent limbs and shift notes. The permit-related polar star gives an at-a-glance look at how closely the process relates to the set point. And finally, what are the top 3 corrective work orders? Level 1 drills down to a single site's current performance data and key performance indicators, KPIs. This is a current level 1 screen. It shows the overall plant well and what equipment is running, but unless you're intimately linked to the plant, it's unclear of what processes are running normal and which ones need attention. Situational awareness comes in, and the screen now focuses less on the layout and individual equipment of the plant and instead on the data and operation. The PIQ, which is the process intelligence of each system, gives the current status of every area. Nominal range KPIs show the set point, optimal range, and alarming limits of each process variable. This is the rolling trend display, and if we jump to a short demo, we'll see that every 10 seconds a new trend is displayed. Showing the past 1 hour to 2 days of data. We can also hit the pause button, and from the drop-down select a specific trend. Navigation can also be accomplished in multiple ways. Clicking the drop-down above each area to choose the desired level, selecting the PIQ to navigate directly to the level 3 screen, or on the KPIs for the level 4 screen. The navigation bar along the bottom will open the corresponding level 2 screen. Level 2 excels at showing process data and status. At the present level 2 screen, we again see a great layout of the area and the operation of some of the equipment, but nothing to help the operator understand how the system has been running. Situational awareness is all about data and is my system running optimal. Devices are only represented as parts of the controller. The PIQ, the Process Control Module, PCM, and pump set statuses all clearly display how the process is running. Microtrends show a historical view without additional navigation, as well as the totals over the past 5 days. The wrench up top shows whether or not there's an active work order in the area. The key concept is to bring the right information to the operator's attention at the right time and in the most intuitive way, such as color to warn if no pumps are available, or if the process is in the optimal range. The current value and its relationship to the set point and alarming limits. A polar star showing the current condition of the area's performance and the top 5 alarms. At every level, situational awareness focuses on the most important data without having to open additional windows. Level 3 is for control and is optimized by providing more intuitive data and system health. Conventionally, for system control, the operator had to navigate down to the device level and then open the setup screen. Situational awareness combats this by removing that extra step and instead providing control at level 3. The process flow diagram appears at this level because it may be useful to the operator to have a visual layout of the system. The right side of the screen is reserved for what was the current setup screen. Here the operator can input set points, enable equipment, or select different modes. But the PIQ is the brains and it controls each process. By selecting the PIQ, the Device Control Interface, DCI, opens up to the right. Here we can put the PIQ in either auto or manual. Here are the manual controls and the out of service toggle. For further information, we can select the Diagnostic tab. The Audit Trail shows the last 10 steps, the PLC setting for set points and time set points, and this area is for the control toggles. Next we select the Steps tab, which displays all the available steps for this PIQ. The true brains of the PIQ reside in the Transitions tab. Here we see the current step and how long it's been here, the previous step, and all the available steps the PIQ could go to based on these conditions, and the minimum or the delay time. As an example, let's hit the rotate button for the blowers. Then go back to the transitions page. We'll see in real time where the PIQ is going and why. The current and previous steps have obviously changed. And here we can see both conditions are met to go to step 7. All we're waiting on is the minimum step time to pass, which we'll fast forward through for this demo. Once the time has elapsed, you see we go to step 7. And after only a couple seconds we head to step 11, where the system is running normal again. During normal operation, the need to see the step progression won't be used as often, but during a not normal situation or system upset, this tool will be invaluable to finding what is preventing us from advancing to the next step or seeing the history that caused the current step. With an aging workforce, operators' experience and knowledge needs to be passed on. Listing the transitions and conditions is one way novice operators can have better process awareness without having to consult the control strategy, saving time and increasing efficiency. Level 4 is now less distracting and more efficient. It shows devices in relation to the layout and their functionality. The traditional Level 4 screen, we see all the equipment and a significant amount of color to show the status, but is red an alarm? Is it normal operation, or is it off? Current PVs are shown, but if we want a trend, we have to select the ones we want, and then navigate to the trend screen. Again, situational awareness gives the operator a better look at what the process is doing now and what it has been doing without further navigation. At this level, the operator has individual device control, such as putting equipment into service, selecting auto or manual, and resetting the equipment. Dark gray is used to show running equipment, while additional color is only used to bring the operator's attention to an event or alarm. And alarms are color-coded now for severity. An operator instantly knows which alarm takes priority. The PV failover shows trending from 5 minutes to 2 hours without additional navigation. And being at the lowest level, we have the narrowest view of how the plant is operating. So now we have upstream and downstream KPIs, so the operator can continue to keep an eye on the area's health. The MDC, multiple device controller, handles lead lag, first on first off, or duty cycle, giving the operator all the information required. The purpose of the PCM is to provide analog PID control for level, pressure, flow, or temperature to either a single device or to be used in tandem with an MDC for control over multiple devices. The Jarvis style display shows the set points in green, PV in blue, and the CO in gray in an easy to view bar or digital display. The add drop limits are displayed when used with an MDC, and a display will show a countdown to let the operator know the time remaining until a piece of equipment is dropped or when it will add. When we select a piece of equipment, the Diagnostic tab on the right can be used for operations and forensics. There's device-specific trending. The Audit Trail lists the last 10 changes the equipment has made, but can be expanded to the last 30 days to look for trends or failures. The Plc Settings gives a more in-depth look at what is expected from the equipment. For example, the pump shows restart delay remaining and how many starts, while the valve will give the interlock action and show the open-close travel times. The equipment work order shows current work that needs to be done on the equipment, as well as repairs that have been made and completed in the past. For additional troubleshooting, maintenance can use the Plc Diagnostic Screen, which serves as a tool to Scada for the Modicon Quantum 652 processors. It displays the current value at each rack slot point, and when opened further, gives a description and scaling of the equipment that has landed there. Now, see how an operator views the plant with the help of situational awareness and the new tools available to diagnose a problem. From the Level 1 screen, we can see the systems are running normally, or out of service. Looking at the KPIs, we notice the fine screen level is slightly above normal. Using the drop-down, we navigate to the Area 100 overview. Here we have the micro trends to show the fine screen level over the past hour, as well as the polar star to quickly show that our system as a whole is running slightly above normal, and therefore we can navigate over to see how the downstream systems are working. They're running normally, everything is within typical range, and the polar star easily shows the system is in balance. Further downstream, we see the clarifiers are also running normally, so we can use the navigation bar along the bottom to go back to Area 100. The fine screen levels have continued to rise, so we can drop down to level 3 to get more information. On our PV failover trend, we can go back to see if there are any patterns. It alarms, but noticing the problem beforehand gives us time to make an informed decision. The alarm has caused the screening controller to go into a not normal state. To see why, the operator goes to the transition page and sees that the PIQ will remain in fast mode until the channel drops below 3 feet. Or if it goes above 3.5 feet, it will interlock the influent pumps. We can now drop down to the level 4 screen to investigate the alarm further. Here at level 4, we can see the fine screens are running fast to clear out any large debris, and the levels are going down, so the extra debris must have been the problem. Once below 3 feet, we can clear the alarms and then check to make sure the PIQ goes back into a normal operation. Even though the levels are below 3 feet, the fine screens are still running fast. Back at the level 3, we select the screening controller again and look at the transitions. It now shows that the level condition has been satisfied, but it will continue to run for 60 more seconds to clear out any remaining debris in the channel. Success. Even a novice operator using situational awareness is able to see where the process should be, what it's doing, and what needs to be done to correct it.